let's now extend the definition of algebraic structure. If you already know that a set with respect to an operation is algebraic structure, and if that operator on that particular set is also going to be associative, then it is called as semigroup, right? So with examples I'll explain you what I mean. Just see this statement: an algebraic structure S comma star. So what does it mean? The set along with the operator with respect to that operator has to be first algebraic structure. What does it mean? It has to be closed, then only we can extend it. Okay, a algebraic structure is called a semigroup if you can see this equation. In this equation it is nothing but associative, right? Associative law. If this associative law, if star is associative on S. Got it? So let's see examples. I'll explain you now. Is n the set of all natural numbers? The set of all natural numbers with the operation addition, is it going to be a semi group or not? So first of all, is it a algebraic structure? That we should understand. Set of all natural numbers on addition is going to be a algebraic structure because set of all natural numbers are closed under the operation addition. Therefore, it is definitely algebraic structure. Fine. Yes, it is algebraic structure, and now you should verify whether it is a semigroup or not. How can you verify whether it is a semigroup or not? You should understand the associativity property, which means if I take any three natural numbers, like let's say A, B, C, and if I perform addition like this, is this result going to be equal to this? If the result is equal, then we can say that it is semigroup. Check this, the result A plus B plus C is of course equal to A plus B plus C. Both are natural numbers. You can take any three natural numbers. Of course this property will be satisfied. Therefore it is definitely a semigroup, right? So this one is definitely a semigroup. Now what about set of all natural numbers under the operation star, which means multiplication? So again, is it, first of all, is it an algebraic structure? It is an algebraic structure because set of all natural numbers are closed under multiplication. If you take any two natural numbers and if you multiply, the result is definitely going to be a natural number. Therefore it is definitely algebraic structure. Now second point you should verify is whether it is going to be a semigroup or not. How can I verify it? The same way, find out this is satisfied or not. A star B star C associativity rule equal to A star B star C. If these two are equal, then we can say that it is associative, and so we can say that it is a semigroup. And as in this case it happens to be semigroup, isn't it? Because if you take any three natural numbers, the whatever way you multiply them, the result does not change. Therefore we can say that this particular this n and star is semigroup. And what about Z and minus? Z is set of all integers and minus is subtraction. First of all, it has to be an algebraic structure. So set of all integers are actually closed under subtraction. If you take any two integers and if you subtract, the result is definitely going to be an integer, and so we can say that it is algebraic structure. And next thing is you should see whether it is going to be a semigroup or not. So which means you should identify whether this minus, the subtraction, is associative or not. So which means if I have A minus B minus C, is it equal to A minus B minus C? So let's take some example and let's see this one. Assume that it is 1, it is 2, it is 3. It is 1, it is 2, it is 3. Now what does the left hand side give you? It is 1 minus 2 is minus 1, isn't it? Minus 1 minus 3 is minus 4. So here I get minus 4, right? And what do I get on the right hand side? 2 minus 3 is minus 1. 1 minus minus 1 is 2. So right hand side is 2 and left hand side is minus 4. So we can say that associativity rule failed. Therefore it is simply an algebraic structure and it is not semigroup because associativity rule failed. So it is not semigroup. Okay, this is semigroup. And what about Q star and plus? So what is Q star is set of all, okay, you need not by heart what is Q, what is Z, what is N. In exam they will clearly mention that. So N is set of all natural numbers, Z is set of all integers, and sometimes they might use a different representation, like they might say capital A and they will say that A is set of all integers. They need not use Z, so don't by heart them. So I'm just telling you here, in exam they will describe it. Okay, so now assume that Q star is set of all rational numbers which are not having 0, which means if Q is set of all rational numbers, then Q minus 0 is Q star. So Q star is nothing but set of all rational numbers not including 0, right? So now what can you say about Q star and plus? So before verifying about the associativity rule, just see whether it is a algebraic structure or not, which means if you take any two rational numbers and if you add them up, then the result should be in the same one. But the problem here is Q star does not contain 0. So if the result happens to be 0, if you take any two rational numbers and then add them, and if the result is going to be 0, then it is not present in Q star, and so plus will not be closed under that, isn't it? So can you find out any such example? If you take any number and add it to the negative of that number, both will be present in the rational numbers. A will be present and minus A will be present in the rational numbers. And now if you add them both, the result is going to be 0, where A is a rational number and minus A is the negative of the rational number, but then 0 is not present there. Therefore set of all elements in Q star are not closed under the operation addition. Therefore we can say that this particular set is not algebraic structure at all. If it is not going to be an algebraic structure, of course it cannot be a semi-group, right? Because semi-group has to be first an algebraic structure, then only we verify the associativity rule. If it fails to be algebraic structure, we need not verify it at all. Got it? Yeah. Now look at the next one, Q star and star. So if you take any two numbers, any two non-zero rational numbers, and if you multiply them, the result is not going to be 0. Therefore it is definitely closed. Definitely it is closed. And we know that multiplication operation is associative. You take any three numbers and you can multiply it, it is always going to be associative. We know that from the basic rules of mathematics. Plus is associative, star is associative, but minus is not associative. Got it? So it is definitely closed. One thing is it is closed, and the second thing is it is associative as well. Therefore it is going to be semi-group. So I think you understood why this one is not closed and this one is closed, because it does not contain a 0, and addition of two rational numbers might give you 0, which is not present here, and so it is not closed. But in this case it does not contain 0, but multiplication of two rational numbers will never give you a 0, right? Two non-zero rational numbers. Why non-zero rational numbers? Since 0 is not present here, when you take two numbers from this set, then you are not going to get any 0, and you are multiplying two non-zero numbers, then the result is not going to be 0. Therefore whatever number you multiply, whatever two numbers you multiply, the result is going to be one number in Q star. Therefore it is definitely an algebraic structure, right? And star is associative, and so it is semi-group as well. So this particular one is semi-group, right? And what about this one, power set of A and union? So first of all you should identify that it is algebraic structure. So power set of A, if I take all the elements of a power set of A and if I apply union, definitely they will be closed. We have just seen in the earlier example. Therefore it is algebraic structure. Now what about associativity? We know that for any three sets, associativity, union is always associative. Set union is always associative. So it is algebraic structure and associative, so we can say that it is semi-group. And the same rule will even apply for intersection. So power set of A and intersection, so elements of power set of A will be closed under intersection for sure. And the second thing is intersection is always associative. Set intersection is always associative. So we can say that it is semi-group. Got it? So I had taken some few sets. In exam they might give you a different set. They might say that there is a R which is set of all let's say this reflexive relations, and then they say comma union. What can you say? Is it a semi group? So first of all it has to be closed, which means set of all reflexive relations should be closed under union. Yes, it is closed. And second thing is union has to be associative, and we know that already union is associative, therefore we can say that it is a semi group. So you have to apply these concepts. It is not that they are going to give the same questions. Yes, in most of the cases you will get the same questions. These are the standard examples that I am taking. You will get the same examples as it is, but in case if they change it, then also you should be able to apply these concepts, right? That is why I try to analyze it this way. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.